like I already mentioned, we'll be doing our experiment 2, which is resistive circuit and measurement of voltages and current. But in your lab manual, it's divided into 2, right? Saying that one experiment is for parallel and series connection. But for the benefit of the lab, we divided it into 2. So one part is going to be for series, and the other part is going to be in parallel. So this is the experiment title. It's in series this time. We're going to do in series. Next week we're going to be doing the connection in parallel. The aim of the experiment, basically, like we explained already, you already know what the Kirchhoff voltage law as well as the current laws are. KCL as well as KVL. KCL was in your quiz. So apply Ohm's law is also one of the aims of the experiment. Remember that Ohm's law, like you stated the last time out, has to do with voltage and current as well. V is basically directly proportional to I. The apparatus here we'll be making use of in the lab will be our power supply, connecting cables, digital multimeters, and 2 resistors. These 2 resistors will be connected in series, not in parallel. Series. This is the circuit diagram. Now, this circuit diagram I mentioned last week, that every circuit diagram that will be drawing here in the lab, okay, on the board, we'll be implementing it practically also when we want to carry out the experiment. So this is a very simple circuit diagram of the resistive circuits and measurement of voltage and current in series, whereby we have 2 resistors connected end to end. One end of R1 is connected to the other end of R2, and one end of R2 is connected to the negative terminal of the power supply. Another end of R1 is connected to the positive terminal of your power supply. Then voltages, the corresponding voltages across R1 and R2 will be measured. The current that is flowing in series will also be measured. According to this circuit diagram, we'll find out that when you connect these 2 resistors in series, the same amount of current that flows through R1 is going to flow where? R2. Very good. Because both terminals, or both ends, or one end of R1 is connected to the other end of R2. So the same amount of current, even if it's 5 milliamperes, that's going to flow in through R1, is going to flow in through R2, and then come out from the other end of R2 back to this power supply. You get? The voltages, however, are measured in parallel, meaning that a particular voltage here in R1 will not be the same with the voltage that will be measured in R2, because the measurements is done in parallel, unlike the current. So that means the total voltage drop here is equivalent to, the total voltage drop is equivalent to V1 plus V2. Have you heard of something like that? And that's what? Kirchhoff's what? Voltage law. Perfect. See, somebody knows. Even if it's just one person, then the person is actually studying. Okay? So the sum of the voltage drops in a closed circuit is equal to the total voltage in that particular circuit. You get? While the same amount of current that flows in through any number, of course, even if you have like 5 resistors in this circuit diagram, the same amount of current will flow in through all of them. We're going to experiment on that. This is just the theoretical aspect. We're going to carry out the experiment and you will verify that it's correct what Kirchhoff mentioned about the current and the voltage laws is still valid even till date. Is this clear? So let's carry out the experiment. Yes. Under the equations, is it I1 is equal to I1 and it's also equal to Yes, exactly. I12 is like the total current is equal to I1 equal to I2. If we have 3 resistors here, it's going to be equal to what? Tell me. Thank you very much. So, you are there. You are there. Any other question before we move into the experiment proper? No other question. Very good. So, let us commence the experiment. To just give, like the last time, just give space. And again, I'm going to explain. And then I'll call you guys out to connect. Just like we did for the Ohm's law. Remember I told you that for the Ohm's law, your connection, as long as you can connect the resistors and then try to measure out the voltages and current that will be flowing across and through the resistors, you will be able to measure accurately the other, in subsequent experiments, you'll be able to measure them very well. So for the R1, again, we are going to be making use of reference voltage 5. Reference voltage 5. Okay? This, remember that our power supply will set it to reference voltage 5. Experiment 1, we had up to 20 reference voltage, right? 5, 10, 15, and 20. But just this one, we're going to be using just one reference voltage. So that's why I put it on top of the table. Don't forget to put it on top of your table. So, again, this is it. We need to do what? What's the first one we need to measure? According to our table, R1, right? R1, very good. But before then, I'll show, okay, let's measure out let us measure out the resistances of this particular resistor, R1 and R2, before we connect them together. And then I'll show you how it looks like. That is going to look like what we had the circuit diagram on the board. Is it clear? So again, this is how you measure. Remember, I'm going to call out somebody to come and measure R2 for me now. So, where do we put it? This is our digital multimeter. Can you remember where we're going to put it? Is it, which of the reds? Is it the V that has the H, or is it amperes or milliamperes? Who can remind me? No. The resistance. The first, of course, the first one from where? Yeah. So, okay, good. You can't say the first one. There are so many first ones. Yeah, exactly. Okay, then the common port. Because again, your resistor has no polarity, right? Until you connect it here, right? So, put it here. And then we twist the knob to 20. Okay, it's already on 20K. You see? 20K. Ohms here. Remember the SI unit for resistance is ohms, right? Oh, we are using kilo ohms in the lab. You turn this one on. Alright, so what we have? Tell me. 9 points. Okay. 9. Second resistance of the resistor. I got it. You don't want to look at me again. Each time I say somebody should come and then nobody's looking at me again. Just like I did for this one. Connect. Yes, very good. Show the camera. Show. Are you seeing what he's doing? I'm going to call on somebody else. Okay. Yes. Turn it on. No. It's already there. Show them. What's it showing you? No.
9.84.
No. I don't want it to be the same resistance. Almost the same resistance. I need to get another one. Hold on. Thank you very much. Just his voice alone has said it. Thank you. Clap for him. Very good. Now, the next one we're going to do is, since we know the resistances of the resistor, now we're going to connect. This is the tricky part. Please listen. We are going to connect both these resistors in series, right? So what do? Like one end of R2 is connected to another end of R1, right? So are you seeing it's in series? This is R1, right? Look at this. This is R1, right? Yeah. And this is R2, right? So this end is connected to the negative of that guy, right? Yeah. And this one is connected to the positive, right? Yeah. So that's our circuit diagram. So R2 is connected to negative. Am I correct? R1 is connected where? Positive. Thank you. That's it. That's circuit diagram. Yes, he has a question.
We are going to measure voltage of both of them together.
Yeah, we're going to measure both of them together, which is will give us R1, R2. We'll measure it here with the multimeter. It's correct. But I need to show us the connection to this power supply. That's the connection basically. So these two now, you now measure it, which will be our R1, R12. Not R1, R2. R12. We put it here again, just like we did in the normal connection. Put it there. What are we seeing?
109.
109.1. 109.1. Point 1, right? Okay, let's see. Now, 2 decimal places, please. 2 decimal places. So this is 90.60, then 10. Okay, kilo ohms. Is that clear?
Yes, sir.
Thank you. Now, we go ahead. So, this one here now, we connect. So like, okay, R negative and then positive. So the voltage and corresponding current will be measured now. Just like we did in Ohm's law, the voltages was measured in parallel, yes. And then the current was measured in series. So, we're going to measure, what's the first parameter we're going to measure? V1. Now these calculated values will come from, you know that, right? Yeah. Under the calculation. That means you're going to be adding this manually. This one is according to what we measured value. This one is calculated value. You get? So when you do those things, you now see, okay, they are almost the same or they are the same. From calculated and measured, you get. So let's continue. So the first one is V1. So we go to, that's our resistor 1, right? Yes. You can see across. So that's V1. Am I correct? And in the circuit diagram. So how do you connect this way? I'm going to do it and then I'll call somebody to come and do another one. See that? So according to this, we are going to check the polarity. This one is positive. So V positive and then common port. So here again, we're going to turn it to V, right? Because now it's in ohms, right? So we turn it to V, 20 volts. We turn our power supply on. Sorry, come and help me check. V, sorry, the reference voltage is 5. Remember, so set it please. Reference voltage 5, turn it on. Thank you. And then turn this guy on. No, the polarity. So, that's another thing you know. I do not trace it very well. So this one means that this one is going to be negative. So we see negative. You get, and this one is positive. So
immediately get negative, you can easily.
Yes, you can easily switch. You will know that the connection is wrong. So I got the negative and I made a mistake, so I had to switch it. Shows because of course when you trace it, this one here goes to the negative, the black. See?
Yes.
So I was the one that made a mistake. So I've corrected it now. What was it giving us? What's the voltage there? 0.50. That's weird, right? It's actually weird. Hold on. Yeah, well, so what's the voltage?
0.50.
Thank you very much. Let's continue. 0.50. So that's for V1, remember. Now for V2, somebody should come and do V2. Come on. Don't be scared, don't be afraid. It is. There is no problem. So this connect with V2, right? So you connect to this guy. This one. Give them some space like this so that. Show them.
You can easily go this way. I don't know.
Okay, yeah, it's right. You can come this way. So tell them what you're doing. Yeah? So you connect, yes? Check which one is positive and negative, right? Check. Put. Just trace the cable. Yeah, so one here. So put this side V and. Show them. Then you just speak now.
So, okay,
Negative, so change it. So ask them, what are they seeing? Ask them.
it's still negative. I think we should on and off it.
Speak, ask them.
So what is it?
4.99.
Yeah, it's not sense. Okay, 4.99. Thank you. 4.99. Okay. Now we're going to do V1, 2. Okay. Now, according to, of course, I've already told you the voltage, the Kirchhoff's voltage law. So it's going to be the sum of each voltage drops. Now, here, how are we going to do this? Now we have it that according to your calculation, the equation here is V12 is equal to V1 plus V2. Am I correct?
Yes.
Now, where is V here? This V is here, basically. Do you believe that? Do you believe?
Yes.
Because the V is coming from the power supply, right? So obviously it's flowing, that's the total V. It's going to be flowing in series. But there are specified voltages that are already, since it's connected, the resistor are connected end to end. There are specified voltages for V1, V2, V3. Then the total of the voltages inside that particular loop is going to be the addition of this. Right? So that's voltage, the Kirchhoff's voltage law. So how are we going to do this to calculate? Look at how you're going to do it. Like I said, it's flowing in series. You can see that that's the total V there, from positive to negative terminal. So it's like this, still in series. You take just like we did in Ohm's law, still the same basic connection, all of them. Take it, put your negative here. See that? So the negative will come here, still on voltage. Don't forget, we're still working with voltage. You're not touching the knob yet. Put it here. And then you turn on our power supply. You're going to see that we are correct in our connection. What's it giving us?
5.49.
5.49. Thank you very much. Now, for current is flowing in series, obviously. Now, we're going to now verify or confirm that this is true. So, we're not sure. It can be or cannot. Let us verify. You can pick one. So, the current flowing in through this guy. Now, irrespective of their resistances, you're going to see it's still going to be the same current. That's the unique part of this experiment. So we connect. So we want to find the current that is flowing through. This can be very confusing, so I'm going to do it, but listen up and look. We want to find R1, right? Which is, okay, let me, please indicate this again. Indicate this on your, sorry about it. Indicate this on your circuit diagram. R1 is flowing this way, right? I1, right? And I2 is also flowing this way. Am I correct?
Yes,
Because it's not as if it's being split. This one is going in here. So this guy is the same. So let me say this is I1, 2. And this is V1, 2. So we reference what we're doing, you know, we're going back, adding some things. You get, do you get what I'm saying? You get it, right? Okay. So, please, any question, you just stop me. Any question, stop me and then we'll review. Just like some of your friends have been doing. Is it clear? Yes. Okay. So, we want to find R1. Sorry, I1.
I1.
Thank you. So, we we'll take this one out because we want to find the current, the actual current that is flowing through this guy. We remove this one because we are talking about R1 first. Plug this one in here. Remember, one end of R1 is connected to positive, right? And the other end is connected to R2. And the other end of R2 is connected to negative. And the other end of R2 still is connected to R1. So we still need to make it a closed circuit. That's why we have it like this. This is R1, right? So we want to know what is flowing into this guy. So we connect it. Alright, so this is negative, right? Negative. And then where am I going to connect this? Remember, where am I going to connect the positive? If I want to find current, where am I going to connect it? Is this still in V or milliamperes? Or milliamperes? Very good. So I put it here. Remember, positive milliamperes. I turn mine up to 8, 20 milliamperes. Yeah. Okay? And then this one is on again. What I have? 0.04. Very good. Listen to this again. 0.04. Close. Take him out. Put it back. Now, once find I2, right? We take it out. The negative part, still like this, is still like that. We plug this one in. Put it here, negative this time. And then this one is positive, right? Should I do it again?
Yes.
Yeah.
0.05 plus or minus, you see? But it's not going to exceed plus or minus 2, definitely. Sometimes, according to, because of these multimeters, we'll be seeing the same precise. So 0.05. Again, we want to do I12, right? So that means any of these two, maybe 0.04 or 0.01 will appear now. So that we'll now know, maybe if they have the highest votes, we win. You understand? We take this one out again and connect this one back. So I12, how do you do it? Since it's flowing in series, you can either remove from here and still do the same connection we just did here, or from here and still do the same connection we just did here. So let's just take I1, no problem. From here. So this one will be positive. Yeah. So you can see that it has gone back again.
Yeah.
0.05. That's the one that is static, right? You turn it off. So that means, remember we connected the first time. The same connection I did last time. That's why I did the first one. It was 0.04. So obviously it's 0.05. So 0.05. See? Quite exquisite. Very nice. So our calculation is what you guys will now do yourself, but I'll just show you. Calculate, you do for your calculation, you're going to be doing R12 as the value you're going to put here. R12 is equal to, what's your R1?
R1 is 9.89.
Thank you. Plus 99.60, all in kilo ohms. What's the answer? Give me calculator. Don't use your head. I know you are very intelligent, yes, but use the calculator. Sorry? 109.48, right?
Yeah.
Kilo ohms. Okay, nice. So, what I have here, 109.48. Now, is this equivalent to this?
Yes.
Just plus or minus 0 point, of course. But you can see it's the same. If you approximate, it's going to give you the same value. Right? Good. So this is correct, right? One of the equations is correct. Am I correct? Now for V, what's our V? 1, 2, V1 plus V2, right? This is R1, this is R2. All in, of course, all in. So we have 0.1 plus, calculate again, 5 point, use your calculator. I don't want to use my own head too. 49 volts, right? Are we correct? So this guy is good. The last but not the least, the current. This is equal to this. Am I correct? So, we are there. Sign, management. So, you should do your report. We are going to, my colleague and I, we're going to upload videos again. If you want to watch it again, no problem. Then from there, you deduce the information you need to deduce, and then you conclude even your results and discussion. You're going to speak results and discussion. Again, those things should not be the same. No graph in this experiment. So the graph in the outline, you can move it, just erase it from your own report, and every other thing you're going to do it. So you submit again on time. You're going to upload the link. So I can submit your lab report 2. Don't forget to submit your lab report 1. Okay? You already know how many percentage that will bring to you. Yes? The question?
Yes. I said, like the experiment is
Let's listen.
The experiment is okay, well understood, but the thing is, like this one, after you done the first one, you go to second, third, you mixing of the cables.
Yeah, it gets confusing, right? No, this one is even partially okay. You know why? You're going to be seeing resistors network. You're going to be using 5 resistors. That will be very, very much complicated.
So how can somebody
There's nothing to be done, because with these cables, it will make you understand better. But I know they are much.
like they know that this cable is this and this and this, connect this and this.
That's what I'm saying, that I know that they are much, but this one is not as much as when we have to start looking at resistors network. So this one is even very okay, believe me. The cables are much, yes, but still. And that's why I try to make it as explicit as possible. You get, trying to show you, after I do the connection, I'll show you, you understand. So you just have, that's how it's being done basically. If we have shorter cables, I would have used, but these ones are very long, but still, the connections will still show you. That's why when I connect, I tell you that is how it is. You get.